Great. Welcome back. Hope everybody had a great lunch. This morning we discussed the application of generative AI in different sectors and different kind of applications. And this panel, we are going to explore more technical details. We have several experts from the computer science major and also have like long time of programming experience. The problem of generative AI, such as hallucination, have been well received in the legal industry, but also the people from the tech industry also try to figure out how to fix this problem, try to reduce the hallucination using different technique to make the system more reliable. And today we are going to listen to our three distinguished panelists. The first one is Marianne Khalusova. She's a staff developer at Unstructured I/O, working on pre-processing unstructured data for generative AI application like retrieval augmented generation. Maria has also contributed to the field through her working at Hugging Face and the educational efforts. And then is Professor Hannes Westermann. He's an assistant professor of law and artificial intelligence at Maastricht University. His research focuses on AI and generative AI for improving access to justice. He developed JusticeBot, a platform that has been used for over 40,000 times, providing legal information for lay people here at Quebec. His research has also been featured in the Financial Times and has won multiple Best Paper Award. And then is Mr. Shiva Bhattacharjee. He's a CTO and co-founder of the True Law company. With 2 decades of experience across software and data system, he leads the development of bespoke AI models for law firms to train systems using their expertise. So, yep, welcome to this panel. And I guess now we could start from the Marianne's presentation.
Sure.
So, yeah.
Thank you. Let me just get behind the desk here. All right. Thank you for the introduction. As was said, I have been in the tech industry for a while. I have spent 18 years in tech. I don't have legal expertise. My expertise lies solely in tech. 5 of those years I have been in AI and machine learning. Currently I work at Unstructured.io. This is a startup that focuses on pre-processing data for RAG applications and other generative AI applications. So this involves pre-processing PDFs, Word documents, images, HTML type pages, and many other document types that are considered unstructured and are unusable in their raw format for RAG applications. Before that, I worked at Hugging Face and I was on the open source team there. And I have co-authored a couple of courses that are available online on deeplearning.ai, on Hugging Face website. And I think one of them got moved to Coursera as well. And in this talk, I wanted to ground the conversation a little bit in the context about how AI and LLMs are made, how they're used in production, what are the limitations that we see, what are the ways of addressing those limitations, what is the role of data in the current applications, and what should be the considerations for building responsible AI. To start, I want to clarify a little bit on the terminology. The term AI and generative AI tends to be used interchangeably. However, this is not the same thing. Generative AI is only part of AI. So if you think about self-driving cars and object detection, that would be a different kind of AI, which is not generative. And they have different issues. So hallucinations are common for generative AI applications, but this is not common for all kinds of AI applications. Here, we are going to be talking specifically about generative AI. And as the name implies, generative AI means that the models generate some content as their output. This can be text, images, audio, code, There are many different applications, potential use cases for these models. Some of them I have listed here, so content creations and virtual try-ons with image models, or code generation, narrating maybe non-player characters in video games, many different potential applications. They all have their own set of limitations, and in this talk, I only have 20 minutes, so I wanted to narrow it down to large language models specifically, because a lot of the issues that we see there, they also will translate to other modalities. Not all of it, but the vast majority. And also, these are the models that kind of launched the whole AI craze, and these are the models that represent the majority of current use cases of generative AI. So if you think about ChatGPT, behind that application, there's a large language model. So I'm going to focus on large language models here. Well, most of you are familiar with the applications like ChatGPT. But what is a large language model that is an AI model behind it? A large language model is a deep neural network with billions of parameters. And what a deep neural network is a combination of mathematical operations, which is designed to process the data and generate some kind of output. Once this model is defined, the mathematical operations are defined, this is the model architecture. But the value of the model comes from the values of those individual parameters. And we get those parameters by training this model. So once you train the model, you get this so-called foundation model. Foundation model is a marketing term mostly. In the scientific community, they used to be called pre-trained models. And so the examples of these pre-trained models are GPT series behind ChatGPT, Llama series from Meta AI, Gemini from Google, and there are many more open source, proprietary, and other kinds of models. Pre-training these massive models requires massive computer resources and petabytes of data, typically scraped from the internet. And for that reason, just for the compute alone and the data and millions of dollars that you have to spend to pre-train such models, for these reasons, only a few companies actually train large language models from scratch. So these are your big tech companies, Google, Meta, Microsoft, but also a few VC-backed startups like OpenAI, Anthropic, Mistral, and a few others. Once these models are released, there are multiple different ways of releasing these models. They can be proprietary, so you don't have access to the weights or how the model has been trained. You can only interact with it either through an API, so programmatically, or within an application. They can be open sourced completely, and in this case you have those values of the parameters called weights. And also the model architecture and training data is sometimes released, and sometimes you have also access to the code. And if you only release the weights of the model and the architecture, this is typically called open weights model. So you can run that model, but you have no way of reproducing that model. And these weights are the result of this extensive training. This is what makes the model work. And so it is important to understand how we obtain these weights. So here's a very simplified recipe for making a large language model. To train a model like that, typically there are several stages of training. The first step is called pre-training. In this step, a model is trained to predict the next word in a sequence on terabytes or even petabytes of data. This is the step that requires the most compute, the most data. This is where you need all those, the snapshot of the internet to feed it into the model and iterate, gradually tweaking those parameters to the point that the model starts to produce the natural sounding text based on the input. A common misconception here is that once the model is trained on these petabytes of data, it can retrieve information from the training data. However, this is not the case. The model only generates the next word that is statistically likely, and it has nothing to do with whether it's factually correct or not. Now, at this stage, sometimes you can see models being released at this stage, and they're called base models. But they're not super useful in the assistant applications because all they do is they just complete sentences, complete paragraphs. They do not answer questions. To make this model into an assistant, you need to do 2 more stages of training. The step number 2 is called fine-tuning. In this step, model is trained again, but on a smaller data set, which consists of question-answer pairs. This data set is typically created by humans, and it's very carefully curated. And the idea is that by exposing the model to this pattern of question-answer, question-answer, it starts to imitate the pattern. So next time it receives the question, it will produce an answer. So we introduce this question-answering behavior. But that's not it. At this point, you can technically use the model as an assistant because it will happily answer questions. But usually there is an extra step involved, which is called reinforcement learning from human feedback. And in this step, we train the model to produce better answers. So what happens here is that we reward the model for good answers, and we don't reward the model for bad answers. And however the good and bad is defined is up to the annotators, up to human annotators. So at this point, we can potentially align the model with our preferences, potentially reduce some of the biases, potentially make it more polite and friendly. And whatever else we want to do, we can make some improvements in this area in the final step. So, a lot of existing regulations about AI concerns these pre-trained models, how the data is acquired, the copyright issue, the personal information on the internet, whether it's used in training or not, how these models are, how they should be regulated based on compute or not. Some of these bills and regulations have been mentioned earlier in the keynote. But what I want to point out is that in the real production systems, we don't just use the LLM itself. And we don't use LLM in production for a number of different reasons. The LLMs, once trained as a helpful assistant, still have challenges. Number one, despite the last step of training when we align the model to certain preferences, they can still propagate bias that has been in the training data. They lack context specific to domain and use cases because they have not been exposed to proprietary data or domain-specific data, and so for that reason, they can produce hallucinations. This is when a model generates a plausible sounding answer which makes no sense within the context. However, hallucinations can even come if the model has been exposed to certain facts. An example of this would be if I ask a model behind ChatGPT to write a 1-paragraph biography of Barack Obama, the result is going to be probably pretty good. If I will ask it to generate a 1-paragraph biography about me, Maria Khalusova, some of it is going to be correct, some of it is going to be hallucinated, because there is some information about me on the internet, but it's not enough. There's not enough information about me in the training data for the answer to be accurate. So don't think that just because some information is on the internet that the model is going to actually be able to not hallucinate on that topic. Next issue is the lack of interpretability, meaning that even though we know how to train these models through an empiric empirical process, and how to make them better on certain metrics, we cannot trace back how exactly the model generated this answer and what each of those billions of parameters do exactly. There is some research into it, but we still approach the whole process as an empirical process. There are a few more things that I wanted to add to this slide. There's a lack of certain capabilities, and these are, for example, not a lack, limitation in certain capabilities. Let's put it this way. Number one, reasoning. The models cannot reason on their own, but they can be prompted in a way to produce outputs that sound like reasoning and then eventually statistically get to a good result. One other issue with the capabilities is a lot of people expect the models to be able to do mathematical operations. Just because we ask it to multiply two numbers doesn't mean that it can multiply two numbers. And you may be asking the model to perform other things that it has not been trained to do. It's a language model. It knows how to form sentences and paragraphs. It has not been trained to do math. And one more technical limitation that sometimes is overlooked is that the outputs of the models are not structured. So if you're expecting the outputs to be in a certain format, you don't get them out of the box. You have some work to do to make them structured. And this is why when we build GenAI applications, we don't just get the model and give it to the user. We build systems around now. And when we talk about LLMs in production, off-the-shelf assistant model is just a component within that system. So how do we mitigate these challenges in production? There are several different methods of improving systems with the LLMs in them. One traditional way of addressing challenges of AI models is fine-tuning them on domain-specific data or proprietary data. This is still done in certain situations. However, it requires a lot of high-quality curated data. Even if you're generating synthetic data, you still have to start with some high-quality data that has been curated by human experts. It can be expensive and time-consuming, especially if you're trying to fine-tune a very large model. And the resulting artifact is going to be static, meaning that if your data changes a lot over the course of time, to keep up with fine-tuning, you will have to go through the fine-tuning process again and again and again and again, and the costs of that can be prohibitive. Other approach to improving behavior is through clever prompt engineering, and there are certain techniques to improve the answers, like few-shot learning. This is when you give a model several examples of how you want it to reply to questions or how you want it to structure their answer. Depending on the use case, you can give it examples to get better outputs. Chain of thought is a way of prompting a model which is quite common. In this way, you instruct a model to produce a reasoning chain of thought first before generating the final answer. And this approach seems to help with questions that require a little bit of reasoning, but not all the time. That's not bulletproof. Next, depending on the application and the challenges that you're facing, you may want to introduce filters and checks around your model. So for inputs that the model is not supposed to reply about, or for outputs that it's not supposed to produce, you can surround the model with all kinds of filters. A very popular approach right now is building agentic workflows. This is when you introduce the use of different tools. So if your model cannot multiply 2 by 3, give it access to a calculator for this specific case. Or you can even have multiple different models collaborating and delegating tasks to one another. This is a very interesting approach because it unlocks a lot of use cases, but also the more models you use, the more different calls to different models you make, the less robust the entire system becomes because it's all very probabilistic and it becomes a lot more complex to make the whole system stable. But this is a very popular approach and a lot of research goes into it. And finally, one of the most commonly used approaches in the industry that we see is retrieval augmented generation. Retrieval augmented generation may sound like a very complicated complex, but the idea is very simple. You give the LLM relevant context. And this context comes from your database, your knowledge base with documents for your proprietary scenario. So for example, maybe you want the model to generate product description for products that are internal to your organization. You give description of those products to the model. If in legal use cases, of course, this could be all kinds of legislation, contracts, and other types of documents. By giving the model relevant context, this grounds the answers and allows the model to generate the answer based on that context. So this tends to reduce hallucinations. This is very popular because it requires no fine-tuning whatsoever. You still can if you want to, and in certain cases you may have to, but normally you can start without fine-tuning. The answers can be grounded in real-time context. If you update your knowledge base in real time, then the context can potentially be real-time. The approach built on decades of information retrieval practices, meaning that you, for the retrieval of the relevant documents, you have multiple different mechanisms that you can use, and they have been battle-tested for decades now. Documents used for RAG can be updated regularly, edited, and removed. Once some knowledge is baked into a large language model, it's nearly impossible to guarantee that it can unlearn it. The documents for RAG, you can just remove from your database. And this system is ultimately very flexible because it's modular. You can update your knowledge base however you want. You can switch an LLM from one to the other. You can change retrieval mechanism, add filters, and so on and so forth. One challenge in RAG is data. If you want to give good context to your LLM, you need to have good data that contains that context. And 80% of enterprise data is unstructured: emails, PDFs, call transcripts, Word documents, and so on and so forth. So this is a massive challenge of extracting text from those documents and delivering it into your vector store, vector database for retrieval. However, this data typically is the one that contains the most relevant context. And the challenges here are not just in the fact that the formats are very different and it's difficult to parse them, but also the data may be contained in multiple different silos, so you have the challenge of aggregating all of the data. And it still may require some cleaning. So for example, if you want to remove personal information from the documents, then you have an additional pre-processing step. So there are challenges in preparing data for RAG. But once you solve that challenge, you can set up processes to thoroughly and thoughtfully aggregate, pre-process, curate, and manage your data. You can build a flexible and dynamic system that can be updated whenever you need to. You can implement those filters and checks. And you can evaluate your system as a whole as well as individual components of that system. You can evaluate the precision of your retrieval. You can evaluate the, maybe like faithfulness and biases in the answers. You can evaluate your business metrics if you want to, and ultimately you have a lot more control over the application as a whole. And as a result, you get a system that generates answers that are grounded in context. This also gives you data provenance, so you can link back to the documents that were used to generate the answers. As I mentioned before, it helps to think about generative AI systems rather than models when building these applications and all the other things that you can add to the system. And since this is a conference on justice, I added that RAG also helps with compliance in the sense that if you need to manage consent and delete data, you can do this because the data is in the vector store. If you have the flexibility to update system components, depending, for instance, you can use one LLM in Europe, you can use a different LLM in the United States, depending on which LLM is compliant in which region. And you get easier personal identifiable information management because that happens at the data pre-processing step and it is not baked directly into the LLM. So that's why there's a lot of excitement about RAG, and I think I went over time, so I'm sorry about that.
No, not there. Oh, there.
Yes.
All right. So we are a startup. We started about 2 years ago. We are, as you can see from our background, we have working on tech mostly. And 2 years ago when we started, we had interacted with LLMs before ChatGPTs of the world. And as we were investigating what is sort of like a fertile ground to apply LLMs to, we stumbled upon legal space as a space that is filled with a lot of corpus of data. It's also aligns very well because if you think about it, LLM as a technology for the first time is sort of bringing you ability to scale cognitive skill sets people have, and there's a lot of those in the legal works domain. And we kind of have always approached, because we don't have JDs and we're not lawyers, we've sort of like approached this problem from a first principles standpoint. And we were lucky to work with some of the very large US law firms using our platform for different types of use cases. Again, we're not going public with what law firms we work with, but that's probably will come out in Q1 of sorts. In general, we identified 3 areas on which we think our approach is unique. There are generic LLM inadequacies stem from the fact that this is trained on a very large set of data, so it actually misses the domain-specific knowledge. If LLM were to become so good that it has both the width and the depth of knowledge, you are kind of very close to AGI at that point. I think there's a way, again, as the models become bigger and bigger, there's more information that it gets from its training. I think we will get higher and higher quality of LLMs. But I think for the precision in law that you would need, I think you have to build more complex systems than the off-the-shelf LLMs that are available. And again, this is something that we got educated even in the law firms that we worked with. This is whole notion of ethical boundaries. What data that you can mix from one client to the other. And I think, again, building your own LLMs and kind of having that control over your data is sort of like paramount for use cases because you have to get client permission to sort of like use their data into the LLM. And then lack of customization. And this is something that, we went to ILTACon and we were seeing a lot of vendors there. The problem with, and I think it was actually shown even in the post-training phase. So fine-tuning approach is something that people do to customize, to align. It's an alignment problem that people go through it. And it's very actually hard to align off-the-shelf LLMs. You can do certain things, and ultimately, even the process of sort of like instruction following is actually, when people say like, you're training it with curated data sets, it's in some ways giving it data sets to, follow instructions. That doesn't come out of the box just by doing the pre-training steps. So it is shown in theory and practice that training an LLM model through data actually does work. I mean, it does work with making these base models into instruction fine-tune or a chat-based LLMs. So we have sort of like taken that approach. And again, I think, our idea here is the solution effectively gets you custom LLMs. So in essence, a law firm can effectively go out there and say that using our data and our lawyers' expertise, we have created unique IP. And that is something a lot of law firms actually want, because otherwise every law firm is sort of like the same. So why would you pay one over the other? The second is you have this extreme capabilities around where you are training the data, even also where you're deploying the data. I think we were working with a Canadian firm which has this whole data sovereignty issues. And I think this has to do with how, especially in that case, how US laws, bank laws are actually very draconian in nature. So they could not have any data that was moving across boundaries. So you have a lot of flexibility in terms of how you deploy these models. And then customizable AI, whereby you're doing these for the specific tasks you're looking for. And again, I think I will repeat that point. Getting that precision out of a task is actually very hard. That is, I think, on these probabilistic models, this is actually very hard to do without. When we looked into it, like the prompt-based approach is the easiest way to do it. And I think it's still a great way for doing exploratory stuff where you're talking to it, kind of giving you responses back. But I think this has benefits to it. But again, if you put in the same prompt, it's not the same answers you get all the time. Just again, back to that whole probabilistic model. And therefore, we think that the approach is to fine-tune smaller language models. So the benefit of fine-tuning is also, you actually don't have to fine-tune the GPT-4 of the world, even though today it is possible through other techniques and efficient parameter training. But you can actually train a smaller 8 billion, 3 billion models. And it is proven that these models outperform larger models in specific tasks. So if you can think of it in a way, you have a bunch of parameters, but you can sort of like train them and scope them well. It might not do the best summary of a Harry Potter movie, but it can do very good classification of an investigation, for instance, a very particular type of investigations. So the other feedback, the other thing that we have heard from the law, I mean, again, this is coming from the law firms that are actually deploying them. They don't want a black box approach. They want to know why the LLMs are behaving the way they are. And I think we have developed a platform that effectively takes this feedback mechanism. So I think it was brought up in the point that the main thing about fine-tuning is this notion that you have to have very curated data set and sort of like understand what you're doing. And I think we have kind of been able to do that, sort of a closed loop where we actually are able to get that highly curated data from subject matter experts like the lawyers doing that. This allows you to then train the model. We have been able to show that when you give feedback on 50 examples versus when you give feedback on 100 examples, the model does incrementally better. Now, this is a thing that I want to say. Like, people have been saying like you can do prompting and do that. This is very hard to do in prompting because it's very brittle. And it depends on a lot of things that you're actually doing, because you take a bunch of examples and you do prompting, and then you want to add 10 more examples, and you want to make sure your new prompt is accounting for all those, the previous one plus the new one. Doing that incrementally is it's very difficult. And like in most cases, what you're doing here is that the examples you have actually chosen are sort of similar. So you're not really capturing a wide variety of examples to train it. So instead of, that idea of kind of making the lawyers who are subject matter experts also become very good at how to do this prompt, and it's very hard for engineers to even do this prompt-based sort of a thing. We believe that they do the best work by critiquing the output of the thing. In normal, like just as you would do as a lawyer to an associate, you critique the work output of it, and we take care of taking that output and kind of converting it into the training data in the context of what kind of task you are training on. And then at the end of the day, you have this very business reason of, ultimately you're creating proprietary IP, because you take a foundational model, you train it with your own data and expertise, and effectively you perturb the weights, and you effectively get a fine-tuned model. That fine-tuned model is yours, and it is specific to the client. Or if you just trained it on your contracts, for instance, you could basically say the firm owns it also, right? And this ability is actually very good for business, because ultimately you can go out there and say, this is our unique expertise. We have the best litigation lawyers, or we have the best IP lawyers, and this is why we have built this sort of a thing. That nobody can give you the feedback on that side. But yeah, we do envision, at the end of the day, there's a lot of questions like, is this going to take away my job? Is this going to do that? I think ultimately we feel like people are going to become more productive. People are not going to do the mundane type of a job. I think a lot of people said here, at least one, nobody wakes up and says, I'm going to do redaction today. That's the thing, So I think a lot of those kind of tasks are going to be automated. You're not going to do repetitive work, so which is also good for in-house legal, who's going to the external counsel for sort of like finding out the same type of things. And so this has a lot of benefits to it. I think ultimately we are enabling law firms to become 10x more productive. And we see that that's ultimately how this particular law firm that we're working with and others, they're looking for different types of revenue model, whereby you can kind of give a subscription basis. So access to law becomes easy because the cost price goes down significantly also. I'll stop with that.
Great. Thank you very much for Mr. Bhattacharjee. And now next, let's welcome Professor Hannes Westermann to introduce his hands-on exploration on the right use cases of generative AI in the legal field.
Great. Thank you for that. So I will be talking about finding the right use cases for generative AI in the legal field and show you some examples of that for hands-on exploration. As Tan mentioned before, I did my PhD here at the lab for 6 years, so it's very good to be back, and I appreciate the invitation. I'll do a brief introduction, and then I'll show 3 projects that illustrate how I think what are some good uses case for LLMs in the law. And then I'll discuss these briefly and then wrap up the presentation. So for the introduction, I want to start with kind of the background and the framing of this, the stuff I've been working on. And that is that of access to justice. It is that lay people have a lot of trouble resolving everyday legal issues, but also interacting with the government and obtaining government benefits. And this is partially due to legal complexity. It is due to struggling filling out forms, and it's due to the cost of going to court. Now, of course, large language models came around a few years ago that are able to predict the next word in a sequence. And as we've seen today, and as I'm sure you're all aware of as well, they are incredibly powerful and can do many things that we weren't able to do before in AI. So a very natural question becomes, how can we use these models to address this issue of access to justice and help these people out that that have trouble resolving their legal issues? So the first approach you might take is why not just ask ChatGPT for legal information, right? So I did this here. I asked ChatGPT what would happen if there was a water leak in my apartment, and I got this very detailed answer here summarizing it through legal articles. But as you can imagine, as soon as I went into the text and these articles, I realized that most of them were wrong, just not matching the number, or the content was not actually there. And we did a more systematic exploration of this. Tan here was the first author of ChatGPT as an artificial lawyer, where we compared ChatGPT and saw how factual it was, finding similar issues there. And this comes down to so Simon Willison, who's a kind of a influencer in this space, phrased it like this: using language models is deceptively difficult. So many of the challenges involving language models come down to this: they look much easier to use than they actually are. And I think that is a great point. And as we discussed before today as well, there are of course still many limitations that limit how they can be used today, involving hallucinations, their kind of confidence in stating facts, even though they might not be as smart as we expect them to be, the bias that could be in there, and of course privacy issues. And I think that as a consequence of this is to see that this is a very powerful thing, but that it's just not the right tool for all use cases. And what I want to discuss today is how do we find these good use cases? I don't think you get an answer for this, but hopefully some more ideas and some questions and considerations that you can take around this question. And I really like a paper called Navigating the Jagged Technological Frontier that essentially explored some of these issues and coming up with a model they call the Jagged Technological Frontier. That is the blue line here. That is the ability of LLMs and AI to do certain tasks, whereas the gray line is the nature of tasks themselves. And as you can see, this blue line is kind of jagged. It covers some spaces, but other spaces it doesn't. And knowing what the difference here is between those two is actually quite difficult, and is what they saw in that paper. And using AI in these tasks where it's not covered actually decreases the performance of the human user. So let's talk about this. Let's talk about some good use cases for generative AI in law. And I want to bring up some considerations that we'll come back to in the end as well. Some questions kind of framing this. First being, who is the end user of the system? Second being, what happens with the output of the system? And the third being, what kind of reasoning is performed on a technical level? How does the system work and interact or be integrated in other AI systems? Great, so first I want to take a look at the Justice Bot. So this was mentioned before today. The Justice Bot is a system that asks users questions to understand a dispute or a problem, then provides legal information and next steps based on the answers given by the user. And it is online in an easy to use tool. So just to very quickly show you how this looks, here's the Justice Bot. These are questions posed in French. For example, are you a landlord or a tenant? And this one is focused on landlord-tenant disputes. And based on the answers you select here, it will narrow down the scope further to try to understand the situation, what has been going on, and give you case law examples to help you understand this. And then finally, if you answer these questions, it will give you legal information. So it might say that, for example, now I said here that I face repeated late payments of rent and that there's a serious issue caused due to this. And I get the information here that I may have issued to terminate a lease if the tenant was not paying their rent on time in many cases. This can of course be very helpful. And now this system is not generative AI. This is a symbolic reasoning system. So I can show you here how it looks on the back end. There's a justice creator that we also developed here at the lab, which essentially contains the kind of symbolic reasoning behind the Justice Bot. As you can see, it's all very clear. It's very logical. So the system behind the scenes kind of traverses this decision tree in order to give legal information. Now, this has a lot of advantages. It allows us to verify that the content is accurate. We can see that the system will always give the same response to the same questions, which of course in interacting with lay people is very important. So, well, you might think, so we deploy this in the House of Landlord-Tenant Disputes with a number of collaborators here at the lab, and then this has to use over 40,000 times. And you might say, based on this, what I just said, that JusticeBot versus ChatGPT, like JusticeBot has an advantage here. But I don't think that's the right way of looking at it. And we are talking about generative AI today. So I think this combination of the two is really what is the interesting thing. And so this is another investigation we conducted as a follow-up, because as you can imagine, building these decision trees can be quite time-consuming. You have to go into the law, you have to understand the legal articles, put it into this format, and then add context. And that can take a long time. So we want to see what about here, can generative AI and LLMs help us with the creating of these pathways? So we published this paper here last year from Text to Structure, where we essentially investigated, can we give ChatGPT a legal article and have it generate from that this legal pathway that lies at the basis of the Justice Bot. So at the left here you see an input. A person may not be an adopter unless he is at least 18 years older than the person adopted, except when the person adopted is the child of the spouse of the adopter. And you can see the logical representation on the right here that kind of puts it into yes and no questions, and based on this is able to come to apply this article. And this was actually generated by the LLM we used for this. So we found this worked very well. In fact, in 90% of the cases, we found that the generated articles were either perfect or they were almost there, only requiring small changes on behalf of the annotator to get them to a state where they could be used for the Justice Bot or as a basis for that. And that is the use case here, right? Like, this is not something we would expose directly to the end user. This is something we would give to a legal expert so that they would read it and they would verify that the logical content makes sense, and fix it and maybe reformulate the language. But this is something that could save a lot of time while still maintaining that advantage of having a logical reasoning system that is safe. So that's the Justice Bot. I'll come back to this to discuss it more at the end as well. Next, I want to briefly talk about the LL Mediator. So that's another project we explored here at the CyberJustice Lab. We want to see can large language models assist in the development of, or assist in online dispute resolution. So people who have a dispute often today are able to use online dispute resolution platforms to negotiate or to find a solution, or maybe there's a third-party mediator who comes in to kind of guide the parties towards a settlement. We want to see here, can GPT-4 assist in this task? And so we built this platform called the LL Mediator, where people can, at the basis, interact in a normal way. There's a chat interface where they can talk. In this case, there's a discussion here about a damaged couch. One of the parties saying, hey, I think you damaged my couch the other day. When will you pay me back? And the other person saying, what are you talking about? I never damaged any couch. So this discussion might proceed for some time, but of course there might be a situation where the parties end up being quite unhappy. They might be upset at each other, and they might want to write a very angry message. You idiot, I know it was you. Might be something that Jane wants to say in this case. Now, if she sends this, this could really influence this dispute, right? Like, it's hard coming back from something like that. The emotions are just going to run really high, and the parties might be kind of taken away from this path towards a friendly resolution. So what happens if Jane tries to send this message in this case? There's this pop-up. It says, we've noticed that your message might contain strong language. We would love to suggest a more neutral formulation. So the system here, instead of saying you idiot, I know it was you, would say, I understand there might be some confusion about the situation with the couch. Could we discuss this matter to clarify what happened and find a way to resolve it together? Sounds much more nice, right? So the idea here is Jane could look at this. She has the choice, right? She could say, no, I want to say what I said. This is important to me. Or she could say, no, that is right. This is a much better way of phrasing it. Or maybe she'll be think herself, yeah, that's true. That's not the best way. I'm going to say something more like that. But she's always in control. This is just suggesting something to her that Jane can then use or not. So later, the dispute might continue for a while, and later there might be a mediator that wants to come into this situation. And of course, they need to read the dispute and draft an intervention. This is also something we use GPT-4 to explore whether that could help with. So what the mediator can do once they've entered this platform is to ask for an intervention suggestion. Here, the LL mediator will read the dispute and act like a mediator. So it will suggest a possible intervention message here, in this case saying, seems there might be a misunderstanding. Jane, could you please provide more details about the situation, such as when and how you believe the couch was damaged? John, please wait for Jane's explanation so we can understand the full context. Again, the mediator can say, yeah, sounds great, that makes sense to me, I'm going to send that. Or they can say, not quite what I wanted, I'm going to change it, or I'm going to write something from scratch. Finally, I want to talk about Dalma. So that's the latest project I've been working on in the Netherlands, in Maastricht. And this stems from the realization that many legal documents, so we saw the structured reasoning on the justice bot and the kind of unstructured reasoning of the LL mediator that was purely based around text, right? But many legal documents are semi-structured. That is, there's some parts of the documents that are fixed, that use very static formulations, then there's other parts that need reasoning, that need a narrative. So here from a paper written by Quentin Steenhuis and some others, they discuss different fields and forms. Some of these are slot and responses, which can be provided without thinking, such as name and address. Others are gathered responses, which will spend the reader some time locating and entering the information. And some are, at the bottom here, created answers, which require the reader to create a new response, draft a narrative, or choose among options that they had not previously considered. And all of these are kind of different. We need different AI approaches to get these, because you wouldn't need an LLM to provide the name, right? That's something the user would provide. But the LLM could be very helpful here in creating answers, in drafting narratives and understanding the requirements of forms and putting it in there. So I'm working on this platform called Dalma, Document Automation Large Language Model Assisted, which is this kind of no-code framework for semi-structured drafting and reasoning with LLMs. I want to quickly show you how this looks. So this is kind of a Dalma, the interface, and this is one of the systems I've built in this just to show how it works. This is a legal issue spotter. So we can put in here a legal issue, and it will ask follow-up questions to better understand and then provide legal information. So let's say here, what are the facts of the case? Let's say I was fired. Is thinking now. Okay, so let's try again. What are the facts of the case? I'm going to say I was fired. And now the system is analyzing this, and it realizes it doesn't quite have enough information. So it asks a follow-up question here. And so the first question was a question I wrote, but this question is written by the LLM. So it's decided, I need more information, I'm going to ask this question here. Can you provide more details about the circumstances of your firing? For example, were there any specific reasons given? I believe it was related to discrimination, retaliation, or breach of contract. I'm going to say I was fired because I was doing a separate business. Also, the boss is my wife. He wants a divorce. Adding some context here, let's see what the model thinks about this. Here it has correctly spotted that there's two issues. First, the employment and the family law. It's actually a more complex case than we initially thought. And what's going on here is that these blurbs here are not written by the LLM. These are written by the creator of the system. But the LLM has done determination here. So the only thing the LLM did in this case was to collect the required information, to decide that this was both a family and employment law issue, and then give this information to the user, which that was done by the logical system. And I can briefly show you how this looks on the back end. Here is kind of a template here. You see there's certain slots. And for each of these slots, we can decide what the models should do, and we can provide very detailed instructions, context that is required, and also different options it can pick. And it is restrained to those options. So there's something that helps with hallucination. There's really a way of constraining the outputs of these models to a very narrow domain. And I think that's quite powerful. I want to briefly show you another example here of reasoning about rent termination. So this is kind of the case you saw before, where there's a landlord-tenant decision where the tenant has been late in paying the rent. So here's kind of how a judge might want to use a system like this. Or there's a hypothetical example where the system does some suggestions that a judge could then accept or deny, but the idea is that the system would kind of follow the logical structure of the law and apply that to a factual situation. So let's say that there's two individuals involved. There's Thomas and Lucas. There's the judge, that's me, that's Hannes in this case. What are the facts? And I can see here on the right here in real time how this is assembled. So as you can see that the answers I gave are already kind of put into this document here. You can see how it's the matter of Thomas versus Lucas. What are the facts of the case? Let's say Lucas is 4 weeks late with paying the rent. And according to Quebec law, there are two kind of causes here. The first being more than 3 weeks late with paying the rent, and the second being frequently late. So the system has correctly realized here that it doesn't have enough information. It's again asking a follow-up question: how frequently has the tenant been late with rent payments in the past year? Let's say 7 times. Now, in order to terminate a lease due to frequent rent payment, there also needs to be a serious prejudice. So we can see here is that the system has written a summary. The tenant has not paid rent for the past 4 weeks. Further, the tenant has been late with paying the rent 7 times in the past year. And it is correctly asking for follow-up information here on the financial or other harm caused. That is, again, one of the legal requirements. And I will say here, yes, they had to sell their car. And again, the model should summarize this and decided that in this case there was serious prejudice and the tenant can be evicted for both these reasons. We could change this so we could see, actually I don't think it's, I can see the answers and I can change it, so I can say what happens if they're only 2 weeks late. I'm going to change this to 2 weeks here. And we can see that the preview changes. There's a different summary, and it decides that there is still a serious lateness, but it is no longer possible to terminate due to the fact of being 3 weeks late. So I think it's a quite interesting approach here to combine these logical rules stemming from the law and stemming from the user with LLMs to kind of constrain the generation. I think it makes sense in the legal field, but obviously there's a lot of things left to do, a lot of things to try to see how that works and how to best employ this system. So to briefly wrap up, we get another robot image here. Now we already got one, but I do think many people really have this vision of LLMs and of AI. I really prefer this vision of it being a tool. It is a fantastic tool. It is definitely one of the most exciting things we've created, in my opinion, but it is also not the right tool for every case. And so if we go back here to these considerations, I think these are kind of helpful in deciding if you have a good use case or not. We have the question of who is the user, and we saw here that some of them were targeted at legal experts that were reviewing these pathways. And in the second case, they were targeted at either the user of the L mediator or at the mediator who would be assisted by this. And then the third case, it could be targeted at many different users. But maybe more importantly, in the second question here, what happens with the output is that in most of these cases, there was always a user who had both the ability in the system, but also the knowledge needed to verify the information by that LLM. So they could verify the logical pathway, of course, to verify that it made sense. They can read the message, the reformulated message, to say, yeah, that matches what I want to say, or that doesn't match what I want to say. But they're always kind of in control. And also the different kinds of reasoning here, from the very structured reasoning of the justice bot to the completely unstructured reasoning of the LL mediator, and the kind of in-between of combining these two approaches in DALMA, that I think is quite exciting. I think what we can draw from this is that LLMs are really very powerful. They're able to carry out many tasks without training through prompting. I think that is exciting. It doesn't always work perfect, but it's definitely we can do stuff that were very hard to do before, especially in the legal field where there's very little training data. I do think for access to justice and online dispute resolution, there are a lot of these very interesting use cases for this. But it is very important to consider the challenges as well, such as hallucinations and other challenges. I think finding the right use cases is really key here, because I am sure there are many use cases right now out there with the systems we currently have. Just got to find them, and I'm sure there's many that we haven't even imagined yet. And I do think this augmented intelligence approach that I presented here is a good piece of the puzzle here, framing them in a way where there's always a user in the loop and the user's assisted in their tasks rather than trying to replace that user. Just a few more thoughts to wrap up. I think it is important to engage in this field. I think there's a lot of excitement here. There's a lot of different things happening. And I think for the people, you guys in this room, I think it's very important to be part of this, because these models are now at a stage where they're able to accomplish many tasks very well, but you are the ones to know which tasks are useful, right? Like which are the bottlenecks in the legal field, and where would it be nice to have these models. And I think like a deep understanding of the use case of what you're actually trying to accomplish is really important in making sure that these models work well. So yeah, I really encourage you to play with them, to develop the intuition for how these models work, and to see what to do with that. Second thing is, the ground is really moving beneath our feet all the time in this field. The developments are so quick that it is kind of hard to keep up what's happening. And it is kind of tricky to conduct research, because if you do a study that shows that something doesn't quite work, in a few months or a few weeks even, there might be a new model that means that it works. So on the one hand, this is quite exciting, because we saw before systems like Dalma and the Justice Bot and El Mediator, they all benefit from better models. These would be integrated there, and they would be even more accurate and even more powerful. But it can also be a bit scary. It can be like, why are we doing this research, spending many months if it will always change? And of course, it can also open many new doors. So just last week, there was a release of this new advanced voice mode for ChatGPT. So I thought I would briefly show you that if you haven't seen it yet, because it's really quite cool, and I do think it has a lot of use cases in the law. So I thought I would. Hello, could you please translate? I'm going to say some stuff in English. Please translate it to French, all right?
Of course. Go ahead and I'll translate it for you.
Okay, so this is the kind of new voice model, and what it does is it enables a very active and very immediate interaction with large language models that we haven't had before. And I think this is something that we didn't have, right? Like, it was very hard to interact with models through voice. They were always quite text-based. But I think today there might be a difference there, and that's something we'll see more of in the future.
Alors voici la traduction en français. C'est le nouveau modèle vocal, et ce qu'il permet, c'est une interaction très active et immédiate avec les grands modèles de langage que nous n'avions pas auparavant. C'était très difficile d'interagir avec les modèles uniquement par texte, mais aujourd'hui, il pourrait y avoir une différence. Et c'est quelque chose que nous verrons de plus en plus à l'avenir.
Okay, so it's a good translation, I would say. The voice is quite natural. And again, this is a large language model, right? It's not trained for translation. Like, this is just because I asked it to do that. But it could do many, many other things. And I'm sure, like, just with this in the legal field, there could be so many different things. I'm thinking of people arriving in court, not speaking the language. Like, having something like this, I think, could really help in those situations. And finally, I want to make the point that to ask what the alternative is. I think we're always comparing these large language models or the AI systems to having access to a lawyer. Of course, in practice, that is not always the case. In fact, in maybe most cases, people don't have the resources or the money to actually speak to a lawyer. So having access to these kind of AI tools that can provide legal information, help people understand their situation, or help them understand which pathways they want to resolve, even if they're not perfect, could already be quite an important step up. Yeah, thank you for listening.
Great. Thank you very much for all these three great presentations. And it's perfect for today's discussion because we saw like different approaches to use generative AI in law. We have like RAG to structure data and provide it into generative AI to provide a more accurate result. And we also have approach of small language model, training on specific data and targeted on specific use cases. And we also, as Hannes just introduced, we use like structured, like extract structured format using generative AI to provide a accurate and deterministic result. So in the moderated discussion, the first question we could talk about is how do you see all those AI techniques and where do you see the future, let's say in 5 years, which approach could be like really change the legal application and transform how we understand legal industry. So Anyone wants to answer?
I can start
Yeah.
by saying that we have no idea what's going to happen in 5 years.
Yeah.
Because the field, the AI research and development moves so fast, it's really difficult to predict what we're going to be working with in 5 years. The techniques that we have now keep evolving, keep improving, so both different RAG applications and generating structured outputs and distilling large models into smaller models and fine-tuning and using visual language models now to interpret images of documents. And it moves so fast that I'm pretty sure we're going to have a lot more of new developments in this domain. We haven't reached the ceiling yet, but where exactly we're going to be in 5 years, it's really difficult to predict, and I wouldn't trust anybody who says who knows where we're going to be in 5 years.
Yeah, I would agree with that. I think the models, like, I mean, it's been 2 years ago only that ChatGPT was released, right, or so. So, I mean, we're really at the beginning of this, and the changes are happening all the time. There are some fundamental limitations at the moment, such as hallucination, things like that. So I feel like that will be a big focus, learning to deal with those or to overcome those. But at the same time, I also think like a lot of the advancements, especially in the legal field, will come more from integrating what we have in the best way that we can. I feel like the work that we saw here today before and other work being performed in different places of like taking the models that we have, trying some use case and evaluating the results and seeing how much can we rely on these, which use case can we use them for, and how can we use these to actually accomplish tasks that are difficult for us today. I think there's going to be a lot of advances just in that, in addition to, of course, whatever we will have in the next 5 years. That is difficult to say.
Great, thank you.
Yeah, I mean, if I were to add anything to that, I think, in essence, there are two main train of thoughts in developing these models. One is sort of this notion that you have a very large model that does everything. And there have been improvements on it. People are exploring different ways and techniques to increase the computational bounds that we have today, using different architectures to increase the context windows. The other train of thought, and to some extent, I think the more pragmatic current way that at least our company, TrueLaw, is invested in that, is this notion of a system of models, or what is known as compound systems. And the idea there is, you build a lot of smaller specific things and you kind of combine them to get to what you actually desire. Now there are challenges to it because you have to do all this coordination and have that stable outcome. And individual things that you're using, like 2 or 3 things to get to, potentially down the road you can have a larger model that kind of does that compound task in one shot. But yeah, I mean, I've been in software industry for almost 20 years, and the speed at which, so I was also part of, the networking stack, the virtualization, the cloud that happened, but at the speed at which these things are increasing, even some of the constraints of computation that we are talking about, there are ways to go around. Like there are things that are being developed where you don't actually have to use the whole 16 bits for storing all that information. There are 1-bit models also that are being talked about. So yeah, some things might be computationally very hard, but it might turn out that we might not even need to do that type of computation. So you see these results where smaller, well-curated data sets are doing much better than training a very large model with very large amount of data. So there are, I think, again, that exploration is going on. The greatest thing here is that there are state actors who will continue to invest on these type of technologies for the foreseeable future. And that can only, increase the speed of development and expertise of these models.